All right, so in this video, we're going to be looking at logarithms and we're going to be expanding and condensing logarithms. So basically what we've already learned is we've learned several different properties related to logs, right? Inverse properties and different things like that so that we can actually, simplify them a little bit depending on what we have. All right, well, with condensing and expanding, we are going to condense and expand, but we're also going to pull back those other properties and simplify as much as we possibly can. So think about what it means to expand. Expand means like get bigger, right? Condense would mean get smaller, just kind of like shrink down. All right, so we have some different properties and we're going to use these three properties to help us do that. But I want you to think back to properties of exponents. Properties of exponents, if you were multiplying, you would end up adding your exponents. If you were dividing, you would end up subtracting your exponents. All right, so it just kind of depends on what you're doing with the problem. All right, so we're going to use those same properties here because exponents and logarithms actually have a relationship, right? So they kind of go hand in hand together. So when we look at this product property, notice that you have the log base u of uv. Well, then you're busting it apart, you're expanding it out, all right, and you're having an addition in the middle. So it's the log base b of u plus the log base b of v. All right. We also have the quotient property where here we're dividing, and notice what we do when we bust it apart. We subtract. All right. So those same properties as before come into play. The one that's going to be a little bit different is this power property. All right. So when you had a power to a power before, what did we do to our exponents? Well, we multiplied them. So similar is this is similarly going to be kind of like that. All right. So here, if you have an exponent, it basically moves to the front and it gets multiplied to whatever that log is. All right, so let's look at some examples because I think that'll make a little bit more sense. All right, so here we have the ln of 6x to the 5. All right, well, that is two separate terms. All right, so we need to bust it apart, all right, because we're expanding it, and expanding it means get bigger, right? So we're going to have the ln of 6 plus the ln of x to the 5, all right? Because 6x to the 5 is technically being like multiplied. So you're busting it apart, and instead of multiply, you're adding. But we have one more thing that we need to notice, all right? We also have an exponent. All right, and this power property up here shows the exponent doing what? It moves to the front. So, but it doesn't move to the front of the whole problem. It moves to the front of the log, or in this case, a natural log of whatever it's attached to. So we're going to rewrite this. It's going to be the ln of 6 plus 5 times the ln of x. All right, so we've expanded it out. All right, so the second example, we don't have an exponent here, but we have the log of 9x. So technically 9 and x are being multiplied. So when we bust it apart, the opposite of multiply, remember, is add. So we're going to have the log of 9 plus the log of x. All right, now that third example, you have the log base 2 of 6x cubed. So that's actually similar to this one, all right? So I'm going to skip over that example for the video because I'd like you to try it on your own, but I want to skip down here to the bottom where I have a few more things, okay, from the you try. All right, so we'll kind of skip around a little bit. All right, so with this first example right here, there's actually 3 different things being multiplied. So don't get confused. You're just going to bust it apart, but instead of having 2 things being added together, you're going to have 3 things being added together, all right? So you would have the ln of 2 plus the ln of x plus the ln of y, all right? And that would be it, all right? So if I come down here to example 4, and we'll skip some of these because I think you'll be able to do those once you see this example. All right, so if we look at example or number 4, we have a lot going on here, okay? First of all, we have two terms up here in the numerator that are technically being multiplied, 2x squared, so 2 times x squared. But then I have something being divided. So remember what we said, multiplication becomes addition. So I'm going to go ahead and deal with that. So I'm going to have the ln of 2 plus the ln of x squared. That's the part in the numerator, the part that's being multiplied. But I'm dividing the y. So I'm going to say minus the ln of y, because that part is being divided. So remember, when you divide, you subtract. Now we're not quite done with that, because we have a what? Exponent. And so we have a square. So the square has to come to the front of whatever term it's attached to. So remember, that exponent gets moved to the front, it becomes multiplication. So what we end up with then is the ln of 2 plus 2 ln of x minus the ln of y. All right, so that is condensing, or not condensing, just kidding. That is expanding. All right, so I'm looking at condensing right underneath it. All right, so now we're going to learn how to condense. All right, so we've learned how to take something that's in its simple form and expand it out, right, which means get bigger. All right, and notice that when you expand it, every term gets the ln, or every term gets the logarithm, whatever it happens to be, okay? But when you condense, instead of getting bigger, you're trying to shrink it all back down, just like these other examples were here, all right? But you don't write the ln or the logarithm like multiple times. You only write it one time, all right? So when we look at this first example here, we have 3 ln of x. Well, think backwards. What did we do before? How did we get this number in the front here? Well, this number came to the front because it was what? Originally an exponent. So we're going in backwards mode right here. All right, so this 3 is going to become the exponent of this x. All right, think backwards. All right, so we're going to have the ln. We're going to write that down one time, because all of these terms are ln. We're going to have x cubed plus tells me to do what? Multiply. So we're going to multiply by 4, and then subtract tells me to divide by 7x. All right, so divide by 7x. So now we just need to clean that up a little bit. All right, so we're going to have the ln of 4x cubed divided by 7x, which we could technically simplify a little bit more, right? Because x cubed over x is really just x squared. So we're going to rewrite that again, the ln of 4x squared over 7. And then this would be our final condensed answer. So remember, you're writing the ln or the log or whatever it happens to be one time, all right, because we're condensing it down. But you do want to simplify anything that can be simplified, all right? So let's look at another example. All right, so with this second example, we have the log base 4 of 12 plus the log base 4 of 5. And I didn't specify this earlier, so I do want to make sure that I talk about this now. Notice that these are both log base 4s. They have to be that same type of log, all right, that same base. You couldn't do this with a log base 3 and a log base 5, for example. It has to be the same. And so far, the other examples, we had either just a plain log or we had like a plain ln or something like that. All right, but these bases do have to be the same. All right, just keep that in mind. All right, so here we have two things. We're going to deal with the log base 4. We're only writing that part down one time. But we have a 12 and we have a 5. All right, well, 12 and 5 are going to actually get multiplied. All right, because, so 12 times 5, because the opposite of the addition for the property is that you multiply. So that would be the log base 4 of 12 times 5, which is 60. All right, and we're going to leave it alone. You could technically actually convert that and get a decimal answer by using the change of base formula. You could do in your calculator the log of 60 divided by the log of 4 and get that decimal answer. But here we're just kind of condensing down that logarithm, so I'm going to let it be. All right. The third example is division because it's subtraction. All right, so we're going to say the log of x divided by y. All right. So basically whatever the log is, you're going to kind of put that out in the front and then deal with your properties. All right. So let's look at another one. All right. So you'll have plenty of practice, so I don't mind doing some more of these. All right. So if we have the ln of 3 plus ln of 6, that means we're going to multiply the 3 and the 6. Subtract means do what? Divide by 9. So we're going to write the ln down one time. We have a 3 times 6 divided by 9. All right, so use your properties. So that would be the ln of 18 over 9, which is really just the ln of 2. Again, I could put ln2 in my calculator and get a decimal answer, but I'm going to go ahead and leave it be. All right, just depends on what you're trying to use it for. All right, so look at the next one. We have a number in the front. So remember, this number becomes what? The exponent of whatever term it's attached to. So we need to keep that in mind when we do this. So everything is, oops, we have another one. All right, so this 3 is going to be the exponent of this x. All right, I almost missed it. All right, so everything is log base 2. So I'm going to go ahead and write down log base 2. But this is going to become x to the 6. Plus means multiply, and this is going to be x to the 3rd. All right, so now we need to clean it up. Well, what is x to the 6 times x to the 3rd? Well, what do you do with exponents? You add them. So this would be the log base 2 of x to the 9. All right, and then that's it. All right, so we've condensed it down. All right, so this last one, why not? There's only one more on the page, right? So this last one, the 3 would become the exponent of the 2. All right, but we have the ln, because everything's ln. We have 24. Minus tells me to divide by 2 to the 3rd power. Well, 2 to the 3rd power is really just 8, right? So this would be the ln of 24 divided by 8, which is really the ln of 3. All right, so hopefully that gives you some examples to help you out here. You are going to expand. Remember, expand means it gets bigger, so you're busting it apart. But every single term when you expand, like if you look at this one, every single term gets the logarithm or the ln or whatever it happens to be. All right, when you condense, you're doing the opposite. You're shrinking it down to as small as you can get it. All right, so we've expanded, we've condensed. There's some problems on page 14 that are practice from the stuff that we talked about in the other video. But if you go to page 15, there's some examples of expanding and condensing here. All right, so some of these are a little bit trickier. So I'll take a look at this one with you, like number 28. You have the cube root of x. And I know that looks kind of weird, but don't like freak out about it. All right, so when we look at that, don't forget that that would be the same thing as log of x to the 1/3 power. So don't forget about what we've learned about exponents and rewriting radical notation to exponent notation. All right, the cube root is the same thing as the 1/3 power. And then we have that exponent. So what do we do to the exponent? Because we're expanding it. That says expand. I don't know. I spelled that wrong for some reason. All right. So we'd bring that 1/3 to the front and we would have 1/3 log x. All right. So that was probably a little bit tricky. If we come down to the bottom of 15, you'll see some of these problems have parentheses. Don't get thrown off by that. We have the log base 3, we're condensing. And we have the x plus 5 in parentheses. Plus tells me to do what? Multiply by 4. All right, well, when you multiply by 4, would you put like 4 out here? No, typically you would put that in front of the parentheses. So I'm just going to go ahead and put it in that right spot. So you could distribute that if you want to, just kind of depends on what you're looking for. But this would be the log base 3 of 4x plus 20. All right, so there you go. All right, So that gives you a couple more examples. Hopefully that helped out some, and that gives you enough to help you get going on your practice.